we had already started the binary classification for the last two classes. Okay. We took one data set, MNIST data set, which is not MNIST, sorry, a handwritten digit data set. Okay. Which is having handwritten digits of 0 to 19. And our task is we have to just identify the files. So if I feed any image to my model, a trained model, my model should identify the content or digit written in that image is a 5 or just not 5. That's it. That is my objective right now. So for that, what we did? So we did of 70K data set is there. Okay. And we split into two parts, 60K for training, 10K for the testing. This is for training. This is for testing. And we did not split into a dedicated validation set, and I want to utilize the cross validation technique to validate my trained model. That is the intention actually. Okay, since my data is very small amount of data is available, usually we should have them lakhs of data should be there, millions of data. Since a very small amount, I don't want to waste my data for the dedicated validation set because I have alternate options. Okay, my model already trained it. So this is the code I have written to train my model. I just choose the SGD classifier model, which can able to perform the classification, binary classification also. Okay. And I train my model by calling the fit method. This is the training features and labels. And after that, I just going to tested my cross-val score, which is just going to give me some 95 points. So here the score, what is the measurement, what is the metrics I use? It is accuracy. We already discussed in the last class. There is with along with the reason why the accuracy is not the right measurement in case of classification. We already discussed with some logic. Correct? So accuracy is not the right metric to use in case of classification task, whether the binary classification or any type of classifications. Okay. So what is other option? Confusion matrix. There is a best one which we should use it to measure the performance of the model in case of classification task. Confusion matrix is the best option actually. Okay. So for the preparation of the confusion matrix, we need to prepare the confusion matrix. For the preparation of confusion matrix, conf matrix, I can say simply, we need the two informations. One is actual labels. We already have it. And predicted labels, red labels. So cross val, since I don't have cross val score is a function, which we already used it. This will always produce me the score, not the predicted values. So, say 60K data, we already we use it for training. For 60K training data, we should know the predicted values of my model during the training phase. During the training phase, my model will predict it and comparing with the actual values, getting the errors and to minimize the error, what is the site is going to update some hyperparameters or some weights of the models. That is the training algorithm. We are going to discuss the training algorithm soon. No need to worry. Okay. So that is my prediction algorithm. So score is not required for me to calculate the confusion matrix, which is like expecting predicted values and actual values. Actual values I already have, labels I already have it. Predicted labels only we want it. For this, rather than using the cross val score, we already discussed cross val predict. There is one more method called cross val predict, which is going to get that the predicted values of the 60K training data during the training phase. So that's what we use it. So cross-val predict function, we already used it. So we are going to give me the predicted values of the 60K training data. Once I know these are my actual labels of my training data, this is my predicted values of my training data, I can able to prepare the confusion matrix. So this is all what we discussed in the last class. Is it clear so far? Anyone have any questions on this still? Up to here? Good?
Yes, sir.
Okay, fine. So now confusion matrices, it is giving an array something like this. What is the array it is giving? It is giving an array of, see what is the values. Okay, so 52, 53, 53 to 63 and 1316. That is one value, one array. And next is 101041. and 4380. So this is a array representation. In matrix representation, I can simply say something like this. Okay, 53263, 1316, 1041, 438180. It's a 2 by 2 matrix, 2 rows and 2 columns. Here also like a 2-dimensional array. Array having 2 elements, and each and every element is also one more one-dimensional array having 2 elements. So this is a represent. Now the question is, what is this values represent? So what is this 1316, 1041, 4380, etc., etc.? What is this values represent? This is what the confusion matrix. Okay, the understanding these values and meaning of these values is really important for us to understand. That's where the major confusion is going to start. So don't think it's too much confused. Okay, it's a very easy to understand. Okay, I'm just going to write it here. For our discussion purpose, I'm going to write in a box form the same values for our easy discussion purpose. Okay. So the first value is equal to 53263, 1316, 1041, 4380. So this is my confusion matrix values. Clear so far? Okay. So understand this one. So there are, what is our objective of the model? We have only 2 classes, 5 and not 5. My model should classify each and every image into either only 2 mutually exclusive classes called 5, or opposite to the 5 is not 5. It's a binary classification. What we call is, it's a mutual exclusive. So I am treating this as a 5. Classifying the image as a 5 is a positive class, because it's a 5 detector is what I mentioned, 5 positive class. This is the negative class. Just for terminology purpose, because I'm going to use this terminology positive, negative from now onwards classification. So that's why I just mentioned positive and negative. Clear so far? This terminology is clear, everyone? Anyone have any questions? Okay, fine. So now with this terminology, the important point is, see here in this box, I have 2 rows and 2 columns. This is my row 1, row number 2, column number 1, column number 2. 2 rows and 2 columns. Agree? So the rows always represents the actual instances. What is the meaning of actual instance? So understand this terminal, understanding these confusion matrix is really confusion. I don't know who kept this name confusion matrix. It's really confusion. But I made this very much simplified so that you can just have some extra focus on here. Okay. If you don't understand this, please let me know. I can explain you once again. Okay, no need to worry. So 53. So what is this row? This row is having 2 values, 53263 and 1316. So forget about the values. Just understand what is the first row represents, second row represents, first column represents, second column represents. Okay, that is what important for us. The first row represents actual negative instance. Negative means not 5 instances. What this means? I have a 60K training data. So a total 70, but I dedicated 60 for training data. In the 60K, so how many are not 5? How many are 5 instances? Instance means in the 60K images, actually, how many are having 5 digit images? How many are remaining image? Remaining means not 5. Means it could be anything, 1, 0, 1, 2, 3, 4, 6, 7, 8, it could be anything, but it's a not 5. Is it clear so far? So I am dividing the 60K images into 2 categories. One is 5 images which contains the 5 digit inside it. Which one is not 5 images. Not 5 images. Clear? So this is represents how many in total. The entire row represents means 523. Okay, 53263. So I'm calculating the not 5 images. These are not 5 images. Actually, 532653, sorry, 53263 plus what is other value? 1316. 1316. What is the value coming? Let me just calculate it. 53263. 54571. Okay. 54579. Sorry, 579. So means in total, in actually, I'm talking about the actual instances. Actual instances, there are 54,000 out of the 60K images. 54,517 images are contains really not 5 digits inside it. The digit could be 0, 1, 2, 3, 4, 6, 7, 8, 9. It could be anything. And coming to the next row here, the next row represents actual 5 instances. Means a positive instances. How many? 1041. So its value should be 1041 plus 4380. Value is coming as, okay, let me just calculate it. What is the value coming as? 1041 plus 4380. 5421. Okay. 5421 is coming as here. So in total, what does it mean is in the 60K images, which contain some different digits inside it, each and every image. So 5 images are, sorry, from the 5421 images are containing the 5 digits inside it. And 54,517 images are containing the not 5. I mean, means any other digit other than 5. Is it clear? Is this concept clear so far? Anyone have any questions on this?
No, sir.
Clear? Everyone? Samyukta, Balakrishna, is it clear? This is only step 1. With only one first point of the image. Is it clear so far?
Yes, sir.
Okay. So now these are the two columns, the rows represents, these are the information. What about the columns information? Let us see the columns information also soon. Okay. The first column represents out of these 60K images, whatever we have, 60K images present here. What during the training phase, what model will do? Model is going to predict each and every image and compared with that digit with the actual label and getting the error and keep on improving the process. Okay, that's a different algorithm. We're going to discuss soon. Actually, no need to worry. So ultimately here, during the training phase, model is just going to predict each and every image. What is the digit present in each and every image? Okay. So now, how many images my model has predicted? Predicted, not actual. Predicted as a not file. There are 60K images are there. There are 60K images are there. Out of these 60K images, how many images my model is predicted as a not 5 and predicted as a 5? Prediction may be wrong or may be right. So I don't care about it right now. So how many my model has predicted as not 5? How many my model is predicted as a 5? That is what my objective in the columns. Or the column is of 52,263 plus 104. This plus this, okay? 53,263. So plus 104. What is the value is? Okay, let me calculate the value. So 53,263 plus 104. 54,304 equal to 54,304. So means my model, out of the 60K images, what the model is taking for the prediction, my model has predicted 54,304 images as a not 5. Okay. And how many images my model is predicted as a 5? Let us see that. So this is my second. This is the one. Okay, this is my predicted 5 instances. This is my predicted not 5 instances. Means images. Clear? So now 1316 plus 4380. So now 1316, sorry, 1316. Write clearly. 1316 plus 4380 is equal to, let me calculate this. 4380. 5696. 56. What this means is, out of the 60K images, what my model is taking for prediction, my model has predicted 5696 number of images as a prediction, predicted as a 5. Out of these predictions, how many are actually 5? We don't know, but these are talking about the predicted values. So now, this is what the figure. Anyone have any questions? So the rows represents out of the 60K, this is my total amount is 60K. 60K, so this much amount is, okay, let me just calculate that. So initially taking as, what is the rows represents? Okay, rows, how many number I forgot? Okay, 5, 4, 5, 4, or I can write in yellow color, also red color. 5, 4, I'll write it here, but 5, 4, 5, 7, 5, 4, 5, 79 is the images, and 5, 4, 2, 1 is the images. And here it is coming as 54304, and next is 5696. So is everyone clear with these numbers? Anyone have any questions on this? So means in the actual 60K images, 60,000 images for the training set, there are 54,517 images are really the not 5 images, and 555,421 images are really 5 images. Is it clear so far? And out of this again 60K images, my model has predicted 54,304 as a not 5 images predictions. My model is made as a 5,696 images as a 5 images prediction. So is this concept clear so far? Anyone have any questions so far? Anyone have any questions?
So one doubt, sir.
Yeah, please.
Sir, now row represents that which is not 5 instance, right?
Which is, yeah, right. Okay, this row you're talking about. Okay.
Yes, sir. So basically, if we go towards the row column, again it says not 5. So how can we include the actual 5 instance in that column?
Sorry, sir. I didn't understand the question. Can you please repeat
Okay.
again?
So basically the row is there, like the first row which is present is actually not 5 integer, right?
Not 5 images present in the training set.
Yes, sir. So
Yeah.
again the column, when it comes to the column, we'll be including the whole column, right?
Correct.
So how do we include even the actual 5 instance, like which is present 1041 under the not?
Yes. And that is what our next step actually. That's so.
Okay.
So here, yeah, the good question is good. That's what our next step. This is only understanding the rows and columns of the matrix so far. If you understand this well, this concept well, then I can move to the next topic. What is each and every number represents? That will discuss it.
Yes.
Okay. So rows represents the actual not 5 images in the 60K training data as a first row, Second row represents the actual 5-digit images present in the 60K. The first column represents the summation of the first column represents the model as how many images the model is predicted as a not 5, and the second column represents how many images model is predicted as a 5-digit images. It's clear so far? Okay. Anyone have any questions so far? Clear? Okay, I'll write the same thing in a very neat fashion. So my rating is not great because we are going to discuss in very detail actually about this. And okay, let me write it here. So okay, this one represents 53263. 53263, 1316, 1041, 4380. Okay, so this is the one, and this is my actual. Okay, how many values are 54579? 5421, 54304, and 5696. Clear so far? Okay. So now what is, you know that now the rows represents the not 5. Okay, actual not 5, and this is called actual 5. This is predicted not 5. This is predicted 5. This is the represents rows and columns represents. Okay. Now let us discuss about what is each and every value here meaning. Understand, this is very, very important. Where the many people gets confused actually. Okay. The first column represents, the first value represents. What is this value represents is, out of this 54,579 images of the actual not 5. So means in my 60K data, my data is having 54,579 images as a actually not 5 images. Out of these actual not 54,579 images, ideally what I should do, my model should do, if my model is making a perfect classification, all to all, this 54,570 images, my model should predict as a not 5. It is a 100% accuracy. Okay, correct? Agree? Let us say, to be simple, 100 images are having 92 images are not 5 images actually, and 8 images are having 5 images. If my model is making a perfect prediction, what my model should do? If I pass these 100 images to my model prediction, my model should say exactly these 92 images as a not 5 prediction, and exactly these 8 images should be made prediction as a 5 image. If this is what my model made during the prediction, I can say my model is 100% perfect accuracy. Is that clear? Correct? So I'm talking about this 92. This 92, if my model is making perfect prediction, this 92 should be, my model should be calculating predicted as a not 5. So the same thing is also, out of this 54,575 not 5 actual images, my model is made only 53,263 images only as a not 5. Means out of this 1316, so 54,579 minus 53,263 images, remaining is 1316. This 1316 images, my model is wrongly predicted. So these, out of this 54,579, 53,263 images, my model is perfectly predicted. Correct predictions. These are wrong predictions. Is it clear so far? Anyone have any questions? Anyone have any questions so far in this one? So I am already mentioned the terminology. Five predictions is positive predictions. Not five is I mentioned as a negative predictions. Since these are negative predictions, so negative means not five predictions, which are correct predictions. I can say word true negatives. So this is a negative prediction, which is correct. Correct. Is that clear so far? Anyone have any questions? Understanding this number meaning is clear?
Yes, sir.
Okay. So coming to this number actually not five images. What my model made? My model decided this as a five images, which is wrong actually. But what is my ultimately what is my model prediction? Is a form. Is my model has considered or classified this 1316 images as a treated as a five images, which is a positive class. Five is a positive class, right? So my model is a positives, but it's a wrong positives, correct? It's a false positives. So remember this word, false positives, you might be hearing many times in your day-to-day working. False positives means, though this 1316 is not positives, sorry, I am not well today, but yeah, forgive me. So, what are this 1316? My model has predicted them as a positive class, which is a 5 class. But ideally, they are not the positive class. They are not 5 images. It's a wrongly considered or predicted as a positive class. It's a false positives. Is it clear? Anyone have any questions on this? False positives 1316. Or to explain in a different way, out of the 54,579 actual not 5 images, my model is predicted 1316 is images as a 5 images, which is a wrong. This is a wrong prediction. That's why I say false positive. Why is it false? False means it's a wrong. Positive means for positive class prediction. Wrongly considered as a positive prediction. Anyone have any questions so far? Is it clear? Anyone?
Yes, sir.
Okay. Coming to this one, the third one. Out of these 60K images, actually 5,421 images are actually the 5 images. Correct? So, but what is my model made a prediction? My model made a prediction out of this 60K images, which is 5,421 is a actual 5 images. Ideally, if my model is saying 100% accurate, what is the case? 8 images are there, 5 images. My model should say all the 8 images should be predicted as of 8, the 5. So in that case, yes, this is also 100% accurate, this is also 100% accurate, total 100% accuracy. But what is happening here? What is this? Okay, sorry. Out of this 5,421 images, so maybe I'll first do this and then coming to here. Out of this actual 5,421 images present in my training set, my model is predicted 4,380 images as predicted as a fake. Means there are actually 5,000, so means 4,008 images by 5,421. So this is my actual files. These are my predicted files. Clear? Out of this 5,421 images, my model is made 4,380 images as a 5. This is true. Means this is correct predictions. True. Positives. Why I'm saying positives? Because it's a positive class prediction. So true positives means correct predictions. And remaining are false negatives. So for false. So out of this 5,421 images, by mistake, my model has wrongly predicted. These 1041 also fives actually, 5 digits. But now what my model said, this 1041 is a not 5 image. This is predicted as a not 5. So false, negatives. Why I'm saying negative? So it's a not 5 prediction. So negative prediction. And it's a false value, false prediction also, false negatives. So true negatives, false positives, false negatives, true positives. Is that clear, everyone? Anyone have any questions on this confusion matrix?